is for maybe you and a partner to take a couple minutes. I'd like you to go through and like plug this first function into your y equals menu, look at the graph, see if you can figure out the y-intercept and if it's a growth or decay function. You and a partner or a group of three or yourself, it doesn't matter. You're just going to try to do these four functions and see if you can start understanding what's happening each time you change the curve. So everyone take their calculator and hit y equals, and let's see what we've got going on. Oh, mine says R. That's from a calculus student. So I need to go to the mode key and change it back to a function. Now I'm going to go to y equals. Now, is that what yours looks like? Clear out if there's something in there. And if your calculator looks like this, and the plot 1 is darkened, you want to arrow up and turn that off, because that was from our scatter plot work last week. Is everybody here now? In the y equals menu, cleared out, no scatter plots. So we're going to plug the first function in, which was 6 times 5 to the x. So 6 times 5, and it's caret symbol under the clear key to the x. And we're all going to hit zoom 6 so that, okay, zoom 6, we should get this as our graph. Zoom 6. It all looks like that steep graph. Might be kind of hard to see on here, but can anyone tell me if that's growth or decay? All right, so let's write in our table that number 1 was growth. Can anyone tell me what that y-intercept is? It's kind of hard to tell, isn't it? How can I know for sure? What would I have to plug into my original equation to find the y-intercept? Remember what you can plug in for x to find the y-intercept in any function? On the y-axis, what does x have to equal? 0. What is 5 to the 0 power? Anything to the 0 power is 1. So what's 1 times 6? So those of you who thought the y-intercept was 6, you were correct. Make sense? Now you're going to do the second, third, and fourth graphs, and you're going to tell me what happens over here, and we're going to make some conclusions for any graph. Let me know if you need help. Did you notice the y-intercept on this one was 0, 1 half? On this one, it was 0, 1. On this one, was it 0, negative 5? Where's that number coming from? I can see them on every question except for this third one. This is really 1 times 1/4, right? Because there's no number in front of it. So guess what? The a value is changing the y-intercept of the graph every time. So a is affecting the y-intercept. Because when you plug in 0, this value becomes 1 times whatever a is. What is the b value doing? So you should have figured out, let's see, this one, was this also a growth curve? This one was decay. This one is kind of like, it's hard to tell, right? Because it's flipped upside down, isn't it? Does it look like this? Is that what that one looks like? Oops. Negative 5 times 3 to the x. What does that look like? See how it's flipped upside down? That's because of this negative 5. But the 3 to the x by itself would have been growth. So that's a weird one. I wouldn't ask you a tricky question like that. So do you see how the b value, 5 to the x, 4 to the x, 1/4 to the x, 3 to the x, that's affecting if it's growth, right? So if b was bigger than 1, it was growth. And if b was less than 1, it was decay, like a fraction, right? Like 2 to the x versus 1/2 to the x. We already kind of knew that from our previous work. All right, so I'll give you a second to write that down. Then I'm going to switch to page 412 to practice this. Has everybody got this part written down? Yay. Okay, 412 should be practicing No, not the resource page. Page 412 is graphs of exponential functions y equals ab to the x. So we did the resource page. You are going to graph these now. These are different ones. Oh, and you know what? You can just write down again how A changed each of the graphs. I think you actually know that now, though. Do we have to graph these? Do you remember what A is going to do? A will be the y-intercept of everything. So let's go over graphing these because I think we just did that basic same exercise. So for each of the functions, start here on the sheet. For each function, state y-intercept and whether the function represents growth or decay, and then evaluate f of 5, which just means plug 5 in, and then they want you to say, how does b change the graph, and they want you to graph the function. So I will walk around and help you, but you should all be on where that arrow is, answering these 3 questions. Okay, are you kind of catching on that the y-intercept is that first value? So 0, 3, that is my y-intercept, but this is controlling the growth or decay, 2 to the x. Page 412. Oh, so this is a growth function. Now on my calculator, I'm going to type in 3 times 2 to the 5th, right? So 3 times 2 to the 5th is 96. That would make sense, I guess. 3 times 32. 2 to the 5th is 32. Okay, so then who can tell me their answers for part B? They think they got all of part B correct. Sophie, you think? What'd you get? Y-intercept of? Perfect. Why did you say it was decay? You're right. Fraction, decay, and what did this come out to? 5 times 0.25 to the 5th. If you guys put it as a decimal, 0.00488. But here's a fancy key on your calculator. It's under the word math on the left side. If you hit math fraction, it will turn your answer into a nice fraction for you, like 5 over 1024. So those are equivalent, but one is rounded and one is an exact answer. All right, who thinks they got all of C correct? Good, go for it. What'd you get for the y-intercept? So 0, 1/2, yep. Growth or decay and y. Y. Well, which number is telling you about growth up here? 5 to the x is growing. Times 5 every day. Wouldn't you like your money to be multiplied by 5 every day? Okay, and f of 5, what's 0.5? Yeah, 1562.5 is what I got on my calculator. So what does B value do? B is the growth or decay factor. So it tells you if it's growing like 2 to the x or decaying like 1/2 to the x. Okay, I want to show you that graphing these is a little bit different than what we're going to do after lunch. You don't have to make a table of values for these. First step would be to find your y-intercept. Sorry, this is a little bit faint. This is 5 times 2 to the x. What's my y-intercept on this one? 5. So I'm going to mark off at 5. 1, 2, 3, 4, 5. What does this 2 to the x tell me to do? It tells me that I'm doubling the number each time. If I start at 5 and I double it, how many would I have? 10. So if I double it once, I'm going to be at 1, is that a 10? What if I double 10? I started at 5 because that's my y-intercept, and this just says to double every time. Double it. So what is 5 times 2? 10. What's 10 times 2? I can't read where 20 is. I think it's the very top, isn't it? All right. What if I wanted to go to the left side? If I go to double it to the right, how do I go to the left? Not negative. I'm doubling, so I'm going to divide by 2 to go to the left. If I'm at 5, what's half of 5? 2.5. What's half of 2.5? If you have $2.50, what's half of that? $1.25. So I'm about there, and I'm just going to get smaller. So I'm going to try to shoot up like that. And then remember, it plateaus here. So you should not go below y equals 0. So I feel like this strategy is an easier strategy if you can wrap your brain around like the y-intercept and doubling it. But it's different from the transformation strategy that we're going to review after lunch. You try the second one now. Think about where your y-intercept will go and think about what you should do each time. I'll give you like 30 seconds to plan it out. I want to put this one up and then we're probably going to lunch. Think about your y-intercept. Where should you start the graph? And what is happening? So each day, if you lost half your money, I don't think you'd be very happy, right? Or now, if you got rid of half of the diseased population of whatever bacteria or deer, maybe that's a good thing. You're reducing something that's bad by half every time. Maybe your sunburn, the area of your sunburn is decreasing by half each day. Or the number of chicken pox. You guys never had chicken pox, did you? I had chicken pox, but if your number of chicken pox went away and healed by a half each day, that would be a good thing. Let's see. My y-intercept is at 2, and if I have half as much each day, then I have like 1, then I would have a half, and I'm going to double it in this direction. 2 times 2 would be 4. 4 times 2 would be 8. 8 times 2 would be all the way up here at 16. Right? So I'm doubling it as I go to the left. I'm halving it as I go to the right. And that's probably where I'll leave you before lunch here. My video and then have people who didn't try it yet try this task. See if you could solve it. It's a little bit like, all right, now I learned this, all these facts about the y-intercept, and why do I care? Well, there is a real life application. So let's see, on this one, you're doing 1/3 times 6 squared. We know that 6 times 6 is 36. So I'm doing 1/3 of 36, which is just 36 divided by 3. So that could be a mental math, or you could plug it in. Probably you don't know 2 to the 5th, but you could do 2 times 2 on your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 times 10, you just add a 0. So your mental math skills, like anything, will get stronger if you use them, right? If you don't use it, you lose it. We haven't used our mental math skills in a while, so we need to keep exercising them. Then on number 5, your y-intercept is 4, and you're doubling it to 8, doubling it to 16, halving it to 2, and then 1, kind of like that. Kind of like that. It'd be great if you knew that there's an asymptote at y equals 0, but we're not quite there yet, probably. This one starts at 4 and gets half as steep each time, so twice as steep, 8, and times 2 is 16, right? Times 2 in the opposite direction if you're going a half. So that would have been 5 and 6. I will keep those up because you're going to write down 5 and 6 if you didn't do them, and you're going to try the 9 and 10 at the bottom. I'd like you to try these in a moment after you get these 6 or other problems done. Without them being like squirming out your hand. Really? Rats. I've heard they're really nice pets. I just couldn't do it. We tried the hamster route. I just could not handle the hamsters. They were too. We do. And they can both do the guinea pig really well. So I'm happy about the guinea pig. What am I looking at? Chip. He's nice. He's a nice guinea pig. And he's a loner, which I kind of like because they produce a lot of food on their own. They have 2 guinea pigs. You know how they're supposed to like live in pairs because they get lonely? Well, Chip was living in a pair with another male, and he was alpha mailing and like attacking the other guy's ear and stuff. So they needed to rehome. They needed to rehome Chip, but he already been handled and everything. So he was like a nice guinea pig for the family. 3. Okay. So if you take a half, what would you have to multiply by to get to 3? 6. So I would say, we'll say you're saying that you're multiplying by 6. Someone else said they think they multiplied by 4 because they estimated that they were at 2 instead. So y equals, so are you writing an equation? Y equals 1 half, because you said you're times 6 to the x, because you said it's growing at a rate of times 6. You made up an equation that made sense for what you estimated. And I would accept more than one right answer. Some people might have estimated that was at 1/3. Let me put up these last 2 here. This is estimating, right? So I would estimate maybe this is about a half. And I probably would have estimated this is at 2, but someone else might estimate it's at 3. So just adjust your equation accordingly. I would say 1 half, maybe times 4 to the x to get to 2, but someone said maybe that's 3. So times 6 to the x, half times 6 would be 3. So it just depends on what do you think it's crossing at. It's hard to see that kind of far away. This looks like it has y-intercept at 2 to me. But then, do you think it's 1 right there? So do you think it's just times half each time? I'd estimate. It looks like it goes 2, then half in my, or 2, then 1. So that's what I would estimate. So could everyone take a look for the last, well, we might have more time after this, but for about 5 minutes on your own, if you haven't had a chance yet,